Powers and exponents. What the heck? Well, an exponent, you may remember from previous math classes, is whenever you have some number, we're going to call it the base, raised to some other number, let's call it the exponent. So the exponent is this raised up number, and the instruction is to multiply over and over. You're going to multiply that many times. But what are you going to multiply that many times? Well, you're going to multiply the base that many times. All of this together, the entire thing all together, is a power. So evaluate, remember evaluate is for an expression. Evaluate b to the 5th power. Well, that means whatever your base is, you want to multiply it over and over and over itself the number of times of the exponent. So in this case, it'd be 5. So you're going to multiply b times b times b times b times b. 1, 2, 3, 4, 5, over and over and over. So let's do some examples that involve real numbers, making it clearer what we're talking about. Let's evaluate 5 cubed. 5 cubed means multiply 5 by itself to itself 3 times. So let's break it down. We'll do the first two. 5 times 5 is 25 times another 5. But 25 times 5 is 125. So 5 cubed equals 125. Well, let's do another one. That was pretty fun. So let's evaluate 4 to the 4th power. That means 4 times 4 times 4 times 4. I'm going to multiply the base 4 times itself 4 times. So 4 times 4 is 16. I can certainly do those two together. And then I'm going to go ahead and do these two together, so I get 16 times 16. I think that's a good grouping to work with. But what is 16 times 16? Well, just going to have to pull out my scratch work here. 6 times 6 is 36, carry the 3. 6 times 1 is 6, 7, 8, 9. And then 1 times 16 is just 16. And remember, you have to scooch over a little bit. Add 6, 9 and 6 is 15, carry the 1, 256. So 16 times 16, or 4 squared, equals 256. Notice what I did. I went right to scratch work. I went right to doing my work by hand. You have to be ready to do that in the real world. You can't always have a calculator or a cheat sheet there. You need to be able to do your calculations on your quickly and without whining. So let's look at another example. This time we're going to take a string of bases. So let's take the letter G times G times G times G times G times G times G. And I want to write this time I want to write this as a power. Well, the base is clearly G, so that part I've got going for me already. And then I just have to figure out what the exponent is. 1, 2, 3, 4, 5, 6, 7. G to the 7th is the same thing as G times G times G times G times G times G times D, G. Well, what happens if I'm asked to evaluate something like x to the 5th, evaluate it? Well, I can certainly expand it into x times x times x times x 5 times, but that really hasn't gotten me anywhere. I haven't come any closer to understanding what this is. What I need, just like in our previous lesson, is I need to know what value I need to be assigned a value for x. So suppose x equals 2. Well, then x to the 5th is the same thing as 2 to the 5th, which is the same thing as 2 times 2 times 2, and 2 more, times 2 times 2. So evaluating this, again, taking 2 of them, that'd be 4. 2 of them, just to make it easier, 4, and then times 2. 4 times 4 is 16 times 2, and 16 times 2 is 32. Or maybe x is 3. In that case, I have to evaluate x to the 5th is 3 to the 5th. So I'm just substituting 3 in for my x. And so that means 3 times 3 times 3 times 3, and one more, times 3. I'm going to chunk it down again just because I find it easier to do that. That's a 9. 3 times 3 is another 9. And then 3 is left over. So 9 times 9 is 81 times 3. I'm going to have to do scratch work again. And you got to be ready to do it. 3 times 1 is 3, and 3 times 8 is 243. So when you're dealing with an expression, a variable expression like this, it can't be evaluated unless you have a value for the expression, for the variable. And it turns out for the variable, many different expressions or many different values can be substituted. You just have to do what you're asked to do, or later on when you're working in the real world, you'll have situations that'll tell you what to substitute into that expression or into that variable. So one real world situation that uses powers and exponents a whole lot is when you're calculating in the real world. Calculating regular shapes, let's say. For example, a regular shape means all the side lengths are the same, or all the measures are the same. So a rectangle would not be regular because you'll have one length for one side and something completely different for the other side. But a square is a regular shape because whatever the length of one side is, the length of the other side is the same, and in fact all 4 sides would be exactly the same. So if I want to calculate the area of a square, then I'd be looking at a times a, which is a squared. So in this case, if a equals 100, so I have a giant square, even though I drew it small, it could represent a giant square, then the area of this giant square is 100 squared, which is 100 times 100. And remember the trick to multiplying hundreds together is 1 times 1 is 1, and then put all the zeros that you have in the final answer. So 1, 2, 3, 4, 1, 2, 3, 4, 100 times 100 is 10,000. Another example would be a cube, a regular cube. If I have a square that's side A, so I have A, and I want to know the volume of the cube that has the same, all of the sides on the cube are exactly the same length. Well, the volume of a cube is side times height. Well, let's say it this way. Hang on. Is base times height times depth. But in a cube, the base, the height, and the depth are all the same. So that would be A times A times A, which is the same thing as A cubed. So if A is still 100, let's change it up. Let's say in this case, we want the side length to be 5. So 5 equals A. To calculate the area of this cube, I would have 5 cubed, which is 5 times 5 times 5, which we already showed in a previous problem, equals 125 cubic measures. So 125 would be the volume of that cube. So regular geometric shapes often have solutions that involve using powers and exponents.